Hey, this video is Calypso programming part 4, and what we're going to do here is this is the NIMS drill press part, and we're going to work with circles, counterbores, some countersinks, and some different types of measuring. So first things first, I want to show you that this thing is capable of showing crashes or collisions, and so I want to show you that before we get going deeper. And on this, I've already done a base alignment. I've taken care of my clearance planes. I've set up my printout as we need to do. And in features, I created my datum, which is the bottom, datum A, the front, and the left end, and I created strategies within those. And that's something I want you to see here. And the strategies for the datum A, I made, you can see I have 4 polylines. 1, 2, 3, 4. Walks all the way around. But sometimes, you know, I didn't want to go all the way around like I just showed you on the last video, because I have tapped holes on my table and we need to avoid that stuff. So this allows me the ability to adjust, okay, by having separate ones. Instead of one, it would be much more difficult. So, but there's a problem, and so let me show you that problem. I mean, it works fine theoretically, but go back to the isometric view. If I run this simulation, same way we've been doing it, move it over here. There's my stylus. Okay, I'm going to run my program. Now, in the last video I ran fast for time. I ran this through fast and it didn't pick up the collisions, so I have to go back to cancel this, making it about halfway like I said. So it went right over and it didn't even recognize the collisions. So here we go. I'm going to run it and you'll see what I'm talking about. Clear the existing, using my base alignment for that. Run. Comes over, it comes down. It's following the little polyline, the first one, then it's going to go to the second polyline directly. Crash right through it. Here we go again. Crash right through it. Okay, so the good thing is I can not destroy my stylus, and I can see this in the video, in the software here, and I can fix it. One last crash. Alright, so I'm just going to make it go faster really quick so we can end this. It's going to do the front and the end. And it's going to give me the report, which there's no data because I haven't set any characteristics. Close this, close this. So, how can I fix this? If I go back into that datum A, and I can go into strategies, there's 2 different ways. Well, there's at least 2. Okay, one of them is I could put a point over here that after it did this, it would go to this point, and then it would go over here. Or I can add this clearance data, which is going to cause it to retract in between. So it's a little bit easier since I really don't want to measure a point over here. So what I'm going to do is pick this one, and then I'm going to, let's see, where is it? There it is, clearance data. Pick it, and it added it in there. Pick the next one, clearance data. Pick the next one, clearance data. So it should run the polyline, come up, move over, run the polyline, come up, move over. So let's see how that goes. Say OK. We're going to go stylus system. Move this back over. Turn the speed back down to halfway. Run it. Make sure it clears the existing. It's over. Goes down. We should see it. It's on this datum B down below. It should come up and go over. There, look at that. Go down. Again, it should come up and go over. So that's probably one of the easiest ways, and I can do that pretty much anytime I want. So that takes care of that. So let me see if I can stop this. Do you want to continue? No. Yes, I know, because I canceled it. So, all right, so now that we got that straightened out, I want to look at doing a hole. Okay, so I got to define the feature, and then how I'm going to evaluate it, and then I'm going to do characteristics. Like I need a location of the hole. I also need a location of the counterbore. Okay, so first we're going to define these things. So I'm going to pick the cylinder. Okay, that's considered a cylinder. I'm going to click it. I'm going to name it. That hole happens to be 375 diameter. Well, I think, let me go look at the print. That hole, diameter 375 plus 6 minus nothing, because I can get it to check the diameter too, and then my counterbore. So let's work with just that diameter first. So here we are. I can say that that is 0.375 plus minus 0, plus 6 minus 0. I'm going to say hole. I cannot have the exact same name when I make it a characteristic, and the characteristic is my size, and when I get my report, it's going to go by the characteristic, not by the feature. So I really want my characteristic to be exact, but I need this to be good enough so I know what to fix if I mess it up. So I got that. I want to get the diameter out of this, D for diameter. A name must not include the following characteristics. Oh, it can't have it divided by. Okay. So I'm just going to call it right 0.375 hole. Because this one, if you look at the print, is also 375. It's just a closer tolerance. Okay, so if you look at this, it's kind of hard to see, but I see a line in there. Oops, I made a point, I think. Let me copy this back out and do a reset. Control V, there we go. So if I can't see, I'm going to unshade it. So what I have here is a circle at the top and a circle at the bottom. So the stylus is going to come in, circle at the top, circle at the bottom. That way I can get, is it perpendicular to the bottom or the top, and check its true location. So there are some things I need to do. So in my strategy, it's got 2 circle paths, one at the bottom, one at the top. So I can, if I want, see, that's way too deep. I can just drag it up. Okay, how deep is it? Well, if I look at my print, that goes all the way through. This is section A, that hole goes all the way through, and there's a counterbore. So I got to be below the counterbore and above the bottom. So there's the counterbore. So I'm going to delete that point that I just made. Oh, really? Nice work, Russ. I deleted the wrong thing. I don't believe there's an undo. So I'm going to reset. There we go. I will take this and drag it up. Let me get a front here. I'm going to take this and drag it down. So I can't move it left or right, which is good. So I'm going to move this up like so. Okay. Because I got to remember my 3mm ball diameter is about a 1/16 radius, so I need room at the bottom and at the top for this. So this is one of the times where using the wireframe is a little bit easier to figure it out. So now I got my distances okay. If I want to be specific, I can go in here and I can change these numbers to exact numbers. Okay. Step width. What's my size? That's right, 0.005. Control C. So on the next one I can do it. Now, angle. When I'm doing a circle, because of the way it enters in and then it goes around and it stops, what you have is you don't totally get a full circle. So what is recommended is you do about 380 degrees. That way there's a little bit of overlap so you get it right. So I will pick that. Now we'll pick the other one. Step width. Paste the 5. Change this to 80. Okay. So there we go. I have that. That's done. And done. So next I'm going to do this counterbore here, the diameter of the counterbore. So I am going to go back to shading it, and I'm going to do this counterbore. So I'm going to pick the diameter, the cylinder. Now if I look at my print, it's 0.13 deep. My the stylus is a 3mm, which is 118 thousandths. Call it 120 thousandths. So the radius is 60 thousandths. So I have to place its depth carefully because it can't go any deeper than 70, because 70 and 60 is 130, and when I'm doing my diameter I don't want to smash the bottom. It'll come up with an error. So I have to be careful as far as how deep I go. So cylinder is it is 750 counterbore, and there is no other counterbore of that size, so we'll just go with 750 counterbore. 0.750 C bore, and we want to know the diameter. So I'll have to go back and look at the other one because I don't remember seeing this. Maybe I didn't pick diameter, but that's its nominal size, 750. My tolerance, according to the print, it's a 2-place decimal, and if I look at the tolerance on my print, it's plus or minus 15. So I can say 15 on that diameter. Go look at my strategy. It has 2 circles. So we need to look at this carefully. Start height is 59. Let's go back and look at which one we're looking at. Okay, the bottom one is the top, and the top is the bottom. So that one, let's go look at it. It's at 70,000, so that's 70 from the top, I think. Let's go look at the other one and see what size it is. it is 59 thousandths. So it's going off at the bottom. So I need this to be 0.07, and it moved it up. Okay, and got to change this step width to 5. Okay, let's pick the other one. Go into there. 70.08. That moved that up a little bit. 8 and 6. Okay, we should be able to get that. So, step width, radius. I'm sorry, 5 thousandths. Okay. 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 So now I have that. Now what I need to do is go back into right hole. See, I didn't check diameter, that's why. Boom. Diameter, look at the print. This was a plus 6 thousandths minus 0 was its size. So I forgot to do the diameter. Okay. Now when I do that in characteristics, it automatically puts diameter. So I can go in here and edit it. Now 750 is nominal size. There's my tolerance. Okay. 375 whole plus 6 minus nothing. So when I pick diameter, it automatically set that up. So next thing I need to do feature-wise is, what's this plane? Oh, change it to, let's go in here and edit this plane. I really want to pick, no, that is not the plane I want, so I'm just going to delete it. Yes, I want to delete it, and I want to pick this surface. Okay, double click it. This is the 0.750 C bore bottom. I don't want to say depth because I want to use depth later. Okay, so strategy, I'm going to do the polyline, and I'm going to accept what it makes. Okay, and what it did was it did 40 thousandths, which is really not enough. Cancel. So I'm going to cancel this, these points, polyline. So I need to be at least a radius away. So I need to be 60, let's go 70. I don't want to touch the side. I just want to touch the bottom. See? And so I got that. Now I'm a little bit farther away. Step width, 5 thousandths. And there we go. So now what I have is diameter and a depth. So really quick, I want to do the depth. So I want to make a characteristic, and I want to do size, distance, Cartesian, and I want to make a distance from, if I pick that, I got to go here. So I'm going to pick here, I'm going to pick this surface. It picks this surface. It calls it plane 1. And the next thing is I picked the box here, and I got this, and I'm going to do the counterbore bottom. Okay, so it did that. Now, nominal distance is 130. That's what it's supposed to be. 0.13 is the way it's called out, which gives me a plus or minus 15 tolerance. Always got to do the tolerances. Otherwise, my info is no good. So, say OK. And this is my 0.750 C bore depth. Gotta label them, otherwise I'll hate it later. So label it. Now I go back to features. When I picked this top surface, it called it plane 1. Okay, there's plane 1. So I should go in here and name it top. Okay, go back here to characteristic, Counterbore. It automatically changed it, okay, because it's sharing the data. Okay, so I have my depths and I have diameters taken care of this first hole. And in the next video, I'm going to show you how to do the location. So that's it for part programming number 4. I'm sorry, Calypso programming part 4.